Welcome to Probability 101 with Dr. Sutton. It is very important that you write down these vocabulary words. We will be using these vocabulary words over the next few weeks. Compound event will be specifically for next week, but please write down this information as soon as possible today. Your vocabulary words: continued, independent event, dependent event, theoretical probability, experimental probability, the fundamental counting principle, and tree diagrams. We will be specifically talking about experimental probability again this week, so make sure that you are really paying attention to the lesson. Your today I will statement is: today I will find the probability of each outcome. And we're specifically talking about a cube in this example. So that I can find the probability using a cube in different situations. You know that you have learned when you are able to do probability or figure out probability in different situations or scenarios. What we want to do in this next example is look at how we find the probability when we're given different colors or different situations. In this case, it's a spinner, and we're trying to figure out the probability of a particular number showing up. A probability problem can be in the form of a fraction or a decimal or a percent. So as seventh graders, you're expected to know how to interchange. Well, in this particular example, everything's a fraction. I have to count the total number of triangular pieces that are in this circle, and then I have to figure out each situation. Well, I see that there's 3 shaded ones, so it must be 3 out of something, and that's 3 out of 8. The probability of me spinning a 1 is 3 out of 8. The probability of me spinning a 2 is 3 out of 8, because there's 3 red 2s, or 3 triangles that are red with 2s in them. And finally, the probability of me getting a 3 as a spin will be 2 out of 8. All of our probabilities in these situations that we work through today should give us 1 at the end. In other words, if I add up all the fractions, I should get the number 1. If you want to look ahead, you might read over this problem and see if you can figure it out, but we will be dealing with compound situations next week. Now let's look at another experimental probability situation. A marble is randomly drawn out of a bag and then replaced. The table shows the results after 50 draws. I could set this problem up as a fraction. The number of red marbles drawn out of the total number of marbles drawn. Remember, we have always said, as of today, it could always be a fraction, a decimal, and a percent. Well, if I take 15 out of 50, that reduces to 3 over 10, and that gives me the decimal of 3/10, which reads just like the fraction, or 30%. By the way, students, there is an excellent iReady that I put into the lesson plan. It's a teacher-assigned iReady that I'm strongly encouraging you to go participate in. That explains experimental probability really well. I strongly encourage students to review the Probability Models iReady teacher-assigned lesson. Theoretical probability is pretty much how it sounds. The probability of getting an even number, if you just look at the theory or the thought process, there are 3 even numbers on a typical die, 2, 4, and 6. So you would take those 3 numbers and put them over 6 in fraction form, and that answer is actually reduced to 1/2. Now I want you to take some time and work through 2 examples. 104 people were asked what is their favorite winter activity. 14 said build a snowman, 69 said skiing, and 21 said sledding. What is the probability that someone's favorite winter activity is building a snowman? Write the probability as a fraction. Number 2, if 500 people had responded, how many would have been expected to list sledding as their favorite winter activity? round to the nearest whole person. Please work on this alone on a piece of paper and see if you can figure it out before we go over the answers. The answer to number 1 is 14 out of 104. You have to think about 14 said that they would build a snowman. And if you take 14 over 104 and reduce it, you get 7 over 52. So don't just automatically look at the number and think, ooh, it probably can't be reduced. Remember your rules about divisibility. For the second problem, 21 out of 104 total people said sledding would be their favorite winter activity. But what happens if that number changed from 104 to 500 people? Well, we would take our 21 out of 104 and we would get the percentage of 20.2. If we take those 500 people but change the 20.2% into its decimal form, which would be 0.202, and how do we do that? We could take that decimal and move it back 2 places, which is basically our division process. And we take 500 times 0.202 and we get 101. Thank you for listening. And don't forget about your iReady assignments this week.